Yes.
Okay. So, Math 243 and 244. I like it when you guys take them sequentially. Or at least if you take both of them. Sequentially is kind of the easiest, you forget less that way. Math 243 was really, up until almost the last week, except with my guys, which was mostly just the last week, you probably did mostly descriptive. Descriptive statistics. Remember what that is from back in the day? What descriptive stats are? Ish. So, I just looked at a Gallup poll this morning. I was making a 243 quiz. That doesn't mean it's automatically descriptive. I mean, I was looking at a Gallup poll. The Gallup poll was Americans' faith in the federal government in international matters and in domestic matters. That's kind of what the poll said. In mathematical form, it chuckled. But the results of that poll, are they descriptive or are they inferential, or could they be a little bit of both?
They're descriptive because they discuss the population and related information.
So if Gallup actually asked the entire population, it has to be descriptive. Because they went and asked the entire population, got all the results together, and put them in a graph, which is spiraling downward according to Gallup. Right? If they did indeed ask the entire population, did they most likely? No. Why? Population's too big. Run out of resources really, really quickly.
They took a sampling.
They took a sample, and the sample then has a margin of error attached to its statistic. Now the statistic from the poll is descriptive. The headline was something like, support for the federal government in faith in domestic and international relations is at new low. Okay, and I always cringe when I see that because I'm like, really, is it really at a new low?
Yeah.
Or is the statistic lower than it has been before? And that, yes, the statistic is lower. So the statistic from the poll was here. But as soon as you try to apply that statistic to the entire population, it's not descriptive anymore. Remember what the other phrase is that we use? What kind of statistics? Yes, inferential, which is a term we didn't use much in 243 because we weren't doing that a whole lot in 243. What's the key word in inferential? Infer. You're inferring something from a sample and making it bigger about the whole population. Now the thing about descriptive statistics, you're 100% sure of what you're reporting on. If you were to ask the entire population, as the Census Bureau does, right? The Census Bureau every 10 years comes knocking on your door. Hey Ben, how many parrots you got in the house? Yep. How many toenails regularly fall off due to fungal infections? Things like that, right? I don't know why I just thought of that. I have no idea why I just thought of that. But if they ask every single American these questions, they then have 100% confidence in the results and the answers. That's descriptive statistics. As soon as you don't ask the whole population, you no longer can be 100% certain in your results. Very often, we are, remember this number from 243? Very often, we're just below 100%, sitting right around at, do you remember? It's okay if you don't. We'll see it again today. 95 is a very, very common number, 95%. I'm not saying it's always the best number. I'm saying it's a very common number. Okay, it's a very common number. So, you're never 100% sure with inference. You're 95 or 99 or 90 or 88, depending on what confidence level you want, which is part of this course, talking about what confidence level you want and learning about what that means. So that's what I want to do today, is I want to mix and match these things. I want to take some of the skills you have from 243 and see how they apply to 244 via a couple experiments, first of which is a deck of cards. Cool? So if you remember yesterday, I had a deck of cards, which we shuffled up, and I said, you guys can leave here as soon as you pull a red card out of my deck. And then I wandered around the room, and you pulled 5 cards out of the deck, none of which were red. So by rights, I could have kept you here for hours until you did pull a red card if it took hours. But because I'm a nice guy, get you out of here at 10, finish class, it's all good. What I want to do today is, well actually, after that happened though, after the 5th black card came out, what were you guys' claims? They were all black? Was that unfair? It was a rigged deck? That's a little more of a general statement than they're all black, right? Maybe there's too many black cards, right? Too many rigged would imply too many black cards. All black is definitely a possibility, right? Could the deck be fair? Right? And I asked that question, you all said yes, it totally could be fair. But then you countered that with what? Say that again. Well, it could be rigged, but assume the deck is fair.
Statistically, it's
one out of two on the average.
Statistically, every second card on average over time should have been red, black, on average over time equalized for time. And then I pulled up an Excel spreadsheet, not the one you're going to use for your quiz, a different one. And I hit F9 a couple times, and then I stopped and turned around, and I'll be damned, there weren't 6 black cards in a row at the very beginning. And I was like, well, that just happened. How unusual could it be? And that's what we're going to learn, how to metric. Metricing your gut. That's what I kind of like calling this course that. It's a way to metric your gut. I don't mean measuring your waistline. I mean, you got a hunch about something. 244 gives you a tool to measure that hunch and decide whether that hunch is just the remnants of breakfast or something statistically is going on and you just noticed it and your gut was right. And sometimes it comes close. That's the thing. Sometimes the gut says something's off and it's almost off statistically, but you've still got that feeling. This gives you this metric. It gives you a way of measuring that gut feeling. So let's metric by a Monte Carlo method. Now, in your quiz for next week, should you choose to do this quiz I'm talking about, there's a Monte Carlo method and also an exact measurement, which we'll get into today. Okay, does anybody know how to use an exact measurement to talk about how unlikely it was to see what we saw last time? It's a 243 question, but you might not remember it right now without more prodding. If I asked you, for example, you pull 5 black cards out of the deck, right, and you're claiming the deck is rigged, and I say prove it mathematically, could you prove it right now mathematically to me? Maybe not right. You have the tools in your mind. I know you do. You might not realize you do at this moment. So here's what I want to do. This is why you have the cards in front of you. This is what computer scientists do all the time. They can probably do the exact mathematics, but they say let's just simulate it instead. So here's what I want you to do. Either as a pair or by yourself. Shuffle your deck up. Deal yourself a card. Make a note of the color that you get. Put the card back in. Shuffle it up. Deal it to yourself again or a friend. Make a note of the color, put it back in, shuffle up, deal again. Do it 5 times. Make a note of the colors that you get. How many red, how many black. If you want to, just do it how many red, because we know we did it 5 times, so we'll know how many black there were. And do that as many times as you can. So sets of 5. Oh, sure, you need some cards. You're good, man. You're good. So do it sets of 5. Collect some data. We'll pull it all together. I know. It's like, oh my God.
I know.
Do you remember the old commercial? You probably don't. This is going back at least 20 years. It's a Powerball commercial. When they were trying to popularize Powerball, and there was a dude with a Powerball ticket sitting at a dinner party. And he's like, the Powerball comes on the TV. He's like, hey, I got one of these tickets. And the first number comes up. He's like, oh, I got one number. His friends are like, whatever, you got one number. He's like, oh, look, I got 2. I got 3. And then all of a sudden, the people in the corner, like, oh, he's got 3. 4. And then the commercial stops when he goes, 5! And it cuts. And it's like, how will you win or something like that? And I'm like, no, probably not, but you know, whatever. But whatever. You guys are pretty small, but the thing is that that's that kind of thing, right? Oh, look, I got 4 black and a over. Oh, it's awesome. Makes me so happy. Makes me so happy. And not yet. I forgot when everybody gets here. And I figured it would be an issue this first week anyway. So, or maybe any week for that matter, right?